Okay, in this video, I'm going to show you how to solve a separable differential equation. So a separable differential equation is one that can be put in the form where we have y prime on one side, and the right side can be written as a product of a function of x and a function of y. So for example, if we have y prime equals x times y squared. Well, this is a separable differential equation because it can be written as a function of x times a function of y. If we write it as x squared times y squared. So to solve this differential equation, we're going to do what's called separate the variables. So we're going to get all the y's on one side and all the x's on the other side. So what I'll do is I'll divide both sides by y squared. So we have y prime over y squared, or 1 over y squared times y prime equals x squared. Okay, so since these two are equal, if I integrate both sides with respect to x, it's going to be equal as well. So what I'm going to do is I'm going to integrate the left side with respect to x, and that's going to equal the integral of the right side with respect to x. Okay, so we should clean up this left-hand side here. So by definition, y prime times dx is dy. And another way we could see why it makes sense is that y prime we can think of as dy dx. So a good way to remember it is we have y prime times dx, so it's dy dx times dx, and that's just dy. Okay, so the left-hand side is now the integral of 1 over y squared. This is dy equals the integral of x squared dx. And now we just evaluate these two integrals. Okay, the left side is negative 1 over y, and we could put plus a constant of integration, but we're also going to get a constant of integration on this side, so we'll just absorb both of them on this side. So we have negative 1 over y equals x cubed over 3 plus some constant of integration. And it's not too hard to solve this for y. Okay, so we have multiply both sides by y and divide both sides by this. We get negative 1 over x cubed over 3 plus c equals y. It'll probably be easier to work with if we clear this denominator, so we can multiply the top and the bottom by 3. So we have negative 1 times 3, or negative 3, divided by x cubed over 3 times 3, so we have to distribute that 3 into this denominator. X cubed over 3 times 3 is x cubed, plus 3c equals y. But now, as c varies over all real numbers, 3c will vary over all real numbers as well, so we can just say that, all right, this is another constant called k. So for our final solution, we say y equals negative 3 over x cubed plus some constant of integration k, where k is a real number. Okay, let's solve this differential equation here. So we start off by recognizing that it is separable since the right-hand side can be written as a function of x times a function of y. And to solve this, we'll separate the variables. So we'll get the y's on the left side and the x's on the right side. So we have y squared times dy dx is equal to x squared. And now we integrate both sides with respect to x. And the left side just becomes the integral of y squared dy equals the integral of x squared dx. So here we get y cubed over 3 equals x cubed over 3 plus a constant of integration. Okay, so let's solve for y here. We'll multiply both sides by 3. We get y cubed equals 3 times x cubed over 3. That's just going to be x cubed plus 3 times c. But just like before, since c is some constant, 3 times c is going to be a constant itself. So we'll just call this k. So we have y cubed equals x cubed plus k, or y is the cube root of x cubed plus k, where k is some real number. Okay, so that's the way separable differential equations work. Get the y's on one side, the x's on the other, and we just integrate both sides with respect to x.